Yeah, so Blueshift, we make thermal protection systems for both spacecraft and aircraft. I'm actually the son of an Air Force pilot. I was born at Lockport Air Force Base. So hey, I love talking about this stuff. Grew up around aircraft. And you may be saying, gosh, vintage Apollo. You know, did Tim get the memo? This is an eVTOL conference and we're not supposed to be talking about spacecraft. Well, you know, I don't know if anybody's following the Artemis program, but it's the US government's effort to get us back to the moon. And we haven't been to the moon since 1972. It's really hard to believe. But as I was studying the Artemis, I noticed they had trouble with their TPS when the Orion spacecraft came back through the atmosphere. Couldn't believe my eyes when they said we were using vintage Apollo TPS. But you're using 1960s technology on a $100 billion 2024 aircraft. So anyway, that's kind of a thread we'll talk about a little bit. The main thing is we see a lot of symmetry with spacecraft and aircraft. Blueshift, we're fortunate to work with a lot of different companies. And so we thought it might be fun to talk a little bit about space and what the AAM mobility market can learn. Okay, so Earth to LEO to the moon and back. That's this concept that, hey, AAM is part of a bigger deal, right? It takes a village. I really liked what Matthew from Rolls-Royce said earlier about being pioneers. Hey, we're all in this together. But there's a lot of activity going on that this industry can leverage. Again, there's that vintage Apollo theme. The mega trends, privatization of the space race. We've seen that impact this industry. Of course, decarbonization of air travel. And then, hey, we're material scientists, so we want to talk a little bit about lightweighting, resource efficiencies, and then thermal protection systems. Kind of a neat chart, right? This is supposed to graphically display all this activity that's going on. If you look really closely at the moon, I don't think I have a pointer. Kind of looks like the man on the moon has a hat. You guys see that? So there's all kinds of infrastructure that's going to actually go on the moon. The thought here is we're going to send astronauts up. They're going to spend as much as 6 days on the surface. And we'll have a moon space station as well. And so the astronauts can be on that as much as 30 days. And then, of course, they're going to need rockets to take them up and back. That's a really significant theme that we're working on. And of course, you got those huge old satellites in GEO, really expensive, meant to last a long time, and they're just not that economical. And so if you look really, really closely in LEO, you can probably see those thousands of satellites, those constellations that are going up. Cheap, inexpensive, economical. Again, a lesson, I think, for this industry. And it's going to be hugely important for the aircraft that we're building for eVTOL. Right? You're going to need great communication networks. No black spots, and so there's huge competition putting these constellations into LEO. And then that's Virgin Galactic's plane. They're doing the space tourism, just barely getting to the Kármán line and coming back down. So all kinds of thermal issues that are going on with these spacecraft and aircraft. You can see an eVTOL down below. So thermal runaway is a big deal for this industry. So a lot of lessons learned that we can share. As we were preparing for this presentation and trying to think of, hey, what might be interesting for this audience, we started to piece together some timelines that we thought were relevant. And our old buddy Elon Musk put out a tweet over the weekend. Do they still call them tweets on X? I'm not even sure. But anyhow, he mentioned that, hey, it was 60 years from the time the Wright brothers flew the Kitty Hawk until we walked on the moon. And so there's this interesting symmetry, right? 60 years from the Kitty Hawk to the modern 737. 60 years later, we've got the MAX 8 is still one of the thoroughbreds for narrow-bodied aircraft. And looking at the space industry, in 26, Goddard flew the first rocket. 60 years later, we have the tragedy of the Challenger. And then we go through this stagnation period, and you look at 2024, we're just getting back to talking about sending astronauts to the moon. All right, so real quick, why did we have this stagnation? Space, you couldn't make a buck, right? Economics have to be there, incentives have to be there. So there really wasn't a financial reason for people to invest in space vehicles. If you think about commercial aircraft, maybe there's just a little bit of design complacency. You have the duopoly, lacking competition. And also thinking about, space was mostly, NASA, the Department of Defense, and the intelligence communities that were doing the investment. So back to Artemis, Artemis versus SpaceX, it's just a huge amount of money invested, right? It's really 10x for the Artemis program versus everything that's been invested in SpaceX. So just, I think, shows how private organizations can more efficiently use resources. Okay, we got pictures of rockets. So a really big deal happened in 2008. SpaceX reached orbit with the Falcon 1. That's actually a picture of the Falcon 9, so don't want to mislead anybody. So that really changed the game, right? A private company got to space with its own money, and so a bunch of other engineers said, hey, maybe I can get to space too. And quite a few of them were ex-SpaceX engineers. But there's a really wonderful book called When the Heavens Went on Sale by Ashley Vance. Chronicles a lifetimes of some entrepreneurs. It's Rocket Lab, Firefly, Astra, and Planet Labs. And so, hey, this audience might find some comfort reading about other people that were really doing some dynamic stuff. Mixed results, of course. If you follow the rocket industry, Rocket Lab has been amazingly successful. Astra has really struggled. And of course, then we've got this big push towards decarbonization that's near and dear to our hearts today. And this is bringing in all kinds of investment. And the reason is, hey, we think we can make a buck. Like, the economics are making sense, and there's huge government support behind it. Privatized investment as well. And of course, lightweighting is a really, really big deal. The faster and higher you want to get off the ground, the more lightweighting matters. All right, the reason we are showing this chart, look at that dramatic slope, right? It's like most of our stock accounts probably the last couple months. It is a geopolitical race. So this is really from like 2020 to 2021 till now. Dramatic uptick in orbital launch attempts. It's the US and China, very geopolitical. But the reason we're showing this is just because of the repetition is making things economical, right? That's a key thing to this. Getting cheaper, right? So 10 years from now, what are the costs going to look like for the eVTOL market? We have no idea, but it's going to be dramatically better. So it's 500 times cheaper to take a metric ton into space with, what we're projecting for the Starship versus how much it costs for the Apollo missions. So a couple more slides on this general theme. Graphically, again, the slopes get really steep as we look into the 2010s and 2020s to now. And just the dramatic decreasing of the cost to move things around. This whole concept of mobility, this market is a subset of a much bigger picture with really good macroeconomics. Here we got one more slide on just the huge effect of decreasing cost and highlighting the Falcon 1. I can't really point to it, but you'll see the Falcon 1 kind of in the middle. You follow that blue line down to the Falcon 9 and the blue line down to the Starship. Just a paradigm shift in how much it is costing to take materials up into space. Okay, all these amazing technologies are converging for this market. So we're a little bit out of space now. We're going to talk about eVTOLs a little bit. And I had some really good conversations last night and this morning about, hey, you know, it is an aerospace market, but there's so much technology that has nothing to do with aerospace classically. So, you know, the computer science around it, autonomy, the battery technology. So, you know, to me, this is, you know, fascinating times. All right, lightweighting is a big deal, master of the obvious, right, within aerospace. It's so much of a bigger deal than with automotive. So I think most folks are finding, hey, you can't really use a lot of automotive technologies for these eVTOLs. And hey, when we talk to our customers, it comes down to grams. Can you save us a few grams of weight? And the CFOs love this too. So it's a great combo conversation with the engineers and the finance guys. But thinking about weight, you know, saving a little bit of weight in your materials allows you to completely change the flexibility of your payload. And I do think economics are just going to be a huge driver for who's successful and who's not. All right, a few minutes on thermal protection. We do have a small table at the back. Danny's back there, and if anybody wants to talk about it in detail, we'd love to do it. But this has changed a lot too, you know, over the last decade. You know, modeling, simulation technologies have really gotten sophisticated. And, you know, all aircraft and spacecraft have at least two dynamics going on, right? They have both transient events and steady state events. And they need to be treated differently. So there's all kinds of considerations to take in. But hey, I think we talked about it being, we need a village to be successful as an industry. And there are so many different materials that can be leveraged now. Great progress in composite constructions, you know, ceramics, all kinds of different materials you can use to create a really sophisticated thermal protection system for your aircraft. Okay, so as we started to think about thermal protection, I get this visual of A Christmas Story and Ralphie's little brother, you know, getting decked out by his mom to go out in the snow. And then I think about, hey, what about an Olympic skier, right? Had a spelt jacket on and lightweight carbon fiber boots. And so our big message to you today is, hey, we want to dress your aircraft like you're an Olympic skier, not like Ralphie's little brother. All right, thank you for your time.
There we go. Thank you ever so much for that, Tim. Really appreciate the presentation.